Hello and welcome. You're with IndiaPostLive.com, India's first live interactive web television. This is your own platform where you can engage with us and talk to us as we discuss various topics. And today we are going to talk about something that India is sure to feel very, very proud of. It is set to make history. Now, 2 days from now, if something that is scheduled to happen today is successful, 2 days from now, India will enter the elite club of nations that is sending a mission to Mars, and that will be successful. Now, let me just tell you exactly what is happening. The Mars Orbiter mission, or the MOM, which is also called Mangalyaan, it was launched from ISRO's Sriharikota on the 5th of November 2013. Today, what's going to happen is the crucial fourth trajectory correction maneuver and test fire of the main liquid engine is scheduled. Now, we are going to learn from an expert who's going to be joining us online as to exactly what the update on that is. But if that happens successfully, what I just told you, then the Mars orbiter will have its scheduled rendezvous with the red planet day after tomorrow, that is the 24th of September. All right, so this is a huge thing for India's space program, and India will become the first Asian country to have a successful project like this, and this is also India's first interplanetary mission. So ISRO, if this is successful, ISRO would become the fourth space agency to reach Mars after the Soviet space program, NASA and the European State Agency. Okay, so let's get an expert in on this right away, and then we'll take you through exactly what ISRO is doing and how. Joining me online is Dr. Arvind Ranade. Dr. Arvind Ranade is with Vigyan Prasar, which is an autonomous body under the Department of Science and Technology, Government of India. Dr. Ranade, welcome to India Post Live.
Thank you. Welcome.
Thank you so much for talking to us. Sir, you are an expert on this, and I did a lot of reading out. I said things like fourth trajectory correction maneuver and test fire of the main liquid engine. Very briefly, from a layman's point of view, can you tell us exactly what this means? What exactly has happened? I believe it's already happened?
Yeah, it has been done at 2:30 in the afternoon.
Yeah.
No doubt.
And it's been done successfully?
Absolutely successful.
Great.
No doubt.
So day after tomorrow, India is entering Mars's trajectory, right? It's entering Mars's orbit?
Yeah, it's called the orbit insertion process,
Right.
thing which will happen at around 7:16 a.m. on 24th of September.
All right. So please tell us a little bit in detail about what exactly the ISRO's mission is all about.
Okay, fine. Little apology for joining a little late, but nonetheless, I will try my best to explain as to my level.
Sure.
See, basically, this Mangalyaan is I would say the first attempt by a nation like us who is still in the developing stage.
Right.
However, what is the importance of showing our capabilities and technology demonstrations to entire globe? Is perhaps the reason is very simple. Like as we know, this Mars has been a source of inspirations and the source of explorations for many years altogether. Certainly, I will talk about Mars later on, but what this particular thing happened today. See, on 5th of November 2013, when Mangalyaan has been launched from Sriharikota, and there were a trajectory correction which kept on happening, and the incremental growth of the orbit has happened for about a month or so. And especially after 1st or 2nd of December, when it was being forced to be in the sun synchronized, or other we call it as sun's gravity assist orbit. Then, in the technical terminology, we call it as a Hoffman orbit, Hoffman transfer orbit.
Right.
And now what has happened is that from that particular point onwards, the velocity of this Mangalyaan was tremendously high. One can even calculate up to the numerical of say 80 to 90,000 kilometers per hour. And in fact, that is what is the speed the Mangalyaan is proceeding. Now, one of the very crucial part of it is, because when it is moving with such a huge velocity, it needs to decelerate. It needs to bring to the very less amount, I mean less velocity, and
right.
the expected number that we are looking for is about 3,000 to 4,000 kilometers per hour, and that is very tremendous job. I mean, and now the point is that what is available with the Mangalyaan is nothing but the available liquid propellers available with it. And one of this, it is called the liquid propulsion motor. I mean, liquid apogee motor. So now this has got about a 50 kg of material sitting inside, and this particular motor was almost dormant for the last 300 days. One can say it's like it was in the sleeping mode, like a Kumbhakaran.
Right.
Now the now important aspect is that it has to wake up at the right time. That is on 24. So it is very essential to test the capability of this motor, whether it will be working to the expectations on the 24th of September. So it was a test fire which has been done around 2 hours and 30 minutes in the afternoon by ISRO. And it was again in the automated mode. And this liquid engine, apogee liquid engine was made it on for just for 3.9 seconds. And within that particular period, about a half kg of this propellant has been used, and it has been tested that this is successfully able to fire the engines at the appropriate speed, appropriate locations, and then it is also able to decelerate the motion, the speed of the Mangalyaan. And this particular process, which has happened for just 4 seconds today, that will go for a 24 minute. That will on the 24th of September.
Okay.
And one of the most critical, and I would say where we always keep the finger crossed, is on the 24th of September, when this particular thing is going to happen. This entire Mangalyaan will not be in the line of sight. In fact, it will not be in the visible horizon for us, because it is going behind the Mars, and everything that is for the 24 minutes is going to be a blackout period for us. So if this is what was the testing that has been happened today, and we are expecting that since it was been successful on the 24th of September, this particular apogee motor, which we are expecting to be continue to fire for 24 minutes, and at the speed of this Mangalyaan will drastically bring it down to the 3,000 to 4,000 kilometers per hour, which will enable us to force it into the parking orbit, which is desired as about 400 kilometers at perigee and about 80,000 kilometers at apogee distance from the surface of the Mars.
All right, all right. So that was a very scientific yet simple explanation of what exactly is happening out there. Before, we have a short video presentation for you, which has been prepared by News Monk Productions. But before we, show you that will actually give you a visual representation, a visual imagery of what Dr. Ranade has just explained to us. But before we do that, Dr. Ranade, there are two people, Swaroop Chatterjee and Palash Khan, and they have been waiting online to talk to us and talk to you. And these people are contestants for the Mars 1 project, the very, very ambitious project, the project which will, which is due to, have Mars as a human settlement from the Earth. Well, okay, I have Palash Khan from Kolkata. Hi, Palash.
Hi, can you hear me?
I can hear you, Palash. Sorry to keep you waiting, but welcome to India Post Live. How are you?
Yeah, I'm fine.
Okay, Palash, you are one of the contestants of the Mars 1 project. Hello, can you hear me?
Yeah, I perfectly hear you.
Yeah, you're one of the contestants for the Mars 1 project, right?
Yeah.
Palash, my first question: why do you want to leave Mother Earth?
Look, this is not the question that why you want to leave the Earth. The fact is that at some point of time we must have to go another planet.
Really?
Because because that there can be some asteroid impact or some viral attack that can destroy the whole human civilization. We must seek for a new planet where we can live apart from the Earth.
All
This will take decades to prepare, and in my opinion, we must have to start from now.
All right.
We have the technology to go to the other planet. And
yes, we seem to have the technology now. Yes.
Yeah, and the most logical planning would be to go to Mars, because there we have the atmosphere, and it is relatively
Similar.
near from the Earth. So this is the next planet where we can go.
Do
That's why
you,
we should we think that we should go to Mars first.
okay, do you have any question to ask Dr. Arvind Ranade regarding what happened today, regarding the India's mission to Mars, the Mars orbiter mission?
Uh, for my question would be like okay, just a minute. So there are there are some detectors that has been installed in the Mars orbiter missions.
Okay.
One is the methane sensor. One is the mission sensor.
Yeah.
So can you explain? If it will be nice if Dr. Roy can explain the method that how it will demonstrate that there will be a sign of life if we detect the methane.
All right, all right. Dr. Ranade, did you get that question?
Yeah, I have heard Mr. Palash, and let me explain in following way.
Yeah.
Yes, certainly this Mangalyaan has about 5 different payloads placed into it.
Right.
And no doubt within the next few months, we are going to get the lot of data from those sensors. But as long as he has asked for the MSM, that is methane sensor Mars. See, basically, this particular Mangalyaan is going to be an orbiter, which will be orbiting around the Mars at the distance of about 400 kilometers at perigee and then 80,000 at apogee.
Okay.
Now, what is there? We actually were expecting to find out the concentration of methane, that too in the upper atmosphere of the Mars. So, in fact, if we are expecting that, that will certainly lead down to give the exact amount of methane which is sitting inside, then it will be a little exaggeration. However, this MSM is going to help us, because ultimately, what are the ways to understand this presence of a methane is nothing but because these instruments are sitting, I mean, at least one can consider at the distance of about 400 kilometers from the surface of Mars. And what is possible by these instruments is nothing but to just keep on taking the photograph in camera manner, or with the spectrograms or the photometer is nothing but the because methane, we know methane is a CH4 and which has the particular wavelength lines if the presence is available. So what we are actually trying to do is nothing but to keep on taking the photographs. I mean, in one way of say fashionably the photograph, but nonetheless it's a kind of a data that we will be keep on gathering. And it will be not that easy to say that within the first few days that what is this the percentage of, but nothing but the depending on the properties of the CH4 and then at what level, okay, what the abundance at what level it is to be there will certainly be come out only after a certain pre-processing of the data as well as the analysis of the data will happen. But nothing but it is what we are going to do is to take the footprints or rather fingerprints of the CH4 available inside the inside or rather one can say in the upper atmosphere of the Mars, and that will help us to tell at least in some numerical way that this is what could be the percentage. And I hope everybody knows that the presence of methane leads down to the exercise of finding out the existence of life in that particular object.
Right. So the first primary objective of the Mars orbiter mission is, of course, to showcase India's rocket launch systems, but also to explore surface features, morphology, mineralogy, and Martian atmosphere. Let me bring in Swaroop Chatterjee now, who joins us from Coimbatore. Swaroop, hi.
Hi.
Hi, welcome to India Post Live, and sorry to keep you waiting there, but how are you? And are you looking forward to go to Mars?
Yes, very much excited. And the recent, the maiden successful, entry into the Mars orbiter is really giving us a lot of hope, and we are looking forward. Just 2 more days to go. We are looking forward, crossing our fingers that ISRO is going to send our MOM very soon, and we are looking forward for our journey.
Right. If this mission, if ISRO's mission turns out to be a success, then this would be not only Asia's first country to achieve this, but also India would be the first country to succeed in its maiden attempt. There have been 21 out of 51 missions that have been successful, but this is India's maiden attempt, and if it's a success, it's a huge thing for ISRO. It's a huge thing for Indian space economy, technology. So, are you feeling proud of Mother, Mother Earth and Mother India?
Yes, definitely. Actually,
And yet you want to leave. Yet you want to leave, huh, Swaroop?
exploration, that is what we are going to look forward. That okay, I mean now we have put our MOM to the Mars orbiter, and next it is the human being. So we are having a lot of confidence that yes, it is definitely going to be possible. So definitely we will look forward for it.
Great.
And we are going to be successful. We are very proud of it.
All right, all right. All right, now for all those of you who have just joined in on the show, and all those of you who also seek a clearer understanding of exactly what this Mangalyaan or Mars orbiter mission is exactly going to do and how ISRO has planned this technology, we have a video for you. The video has been prepared by Newsmonk Productions. I'll take a look at it, and probably, at the beginning of the show, Dr. Arvind Ranade explained it to you, but this is a visual imagery of exactly how it works, how the trajectory works, how we will push the mission from, out of the Earth's atmosphere into the orbit of Mars. Here it is. Take a look. It's very interesting.
Mangalyaan, India's first mission to Mars, left the Earth's orbit on December 1st, 2013. When it reaches the red planet on September 24th next year, it would have covered a distance of 780 million kilometers in 10 months. But here is an intriguing question. Mangalyaan was launched from Sriharikota on November 5th and kept orbiting the Earth for 25 days before setting off for Mars. Why? After all, NASA's maiden mission, which took off 15 days after Mangalyaan, went straight to Mars. This is how it worked. On November 5th, the PSLV put Mangalyaan in a low elliptical orbit, with a minimum distance from the Earth of about 240 kilometers and a maximum distance of 24,000 kilometers. Technically, the minimum distance is called the perigee and the maximum the apogee. When the satellite is placed in orbit, it does not require additional fuel or energy. It keeps on moving, much like the Earth moves around the Sun. But at what speed does the satellite move? Well, this is determined by two things: distance from the Earth and the shape of the orbit. The closer the satellite is to Earth, the faster its speed as the gravitational pull is higher. As far as the shape of the orbit is concerned, the more elliptical the orbit, the higher is the speed of the satellite. Now let's see how ISRO used two principles to increase the speed of the satellite. According to the first principle, when the satellite is at the perigee, its speed is at its highest. So if you give the satellite a little push when it is there, you can make it move a long distance. When the satellite is at its perigee, the mission controller in Bangalore often fire the motor on board to push the satellite into a higher, more elongated orbit, thus increasing the speed of the satellite significantly. Between November 5th and November 16th, ISRO made 5 orbit-raising maneuvers, increasing the apogee to 1,93,000 kilometers, which is 8 times the height at which the satellite was first placed. This pushed the speed of the satellite to nearly 11 kilometers per second. which is close to the escape velocity. So all that the mission controller needed to do on December 1st was to burn the motor one more time and push the satellite out of the Earth's sphere of gravity into the Sun's gravitational influence. Since the Earth is orbiting around the Sun at a speed of 1 lakh kilometers per hour, Mangalyaan exited the Earth's sphere of influence with the same speed, plus the additional push given by the motor. The new orbit around the Sun that Mangalyaan will follow is called the transfer orbit or the Hanuman orbit. At some point, this orbit will intersect with the orbit of Mars. The timing of the mission has been carefully planned to ensure that when Mangalyaan reaches the point of intersection, Mars itself will be there to meet it. The satellite will then fire its onboard motor, but this time in reverse direction to slow down its speed, so that Mars can take Mangalyaan into its own gravitational sphere of influence. Mangalyaan will then start orbiting Mars for about a year. So, if anybody ever asks you, why is it that traveling to Mars takes only as much fuel as traveling to the Moon does, even though Mars is about 100 times more distant than the Moon, you know the answer. Most of the fuel we need is just to launch the satellite. The rest of the journey is mostly courtesy of gravity. If only we could travel with such ease down here on Earth.
Such a long journey on a polar satellite launch vehicle or a PSLV. Dr. Ranade, did you see the video?
Made, and I really appreciate the efforts that has been put by the
Isn't it? It makes it so simple. You really understand what is happening and how the escape velocity is being reached and how the Hanuman trajectory is, connecting with the Mars's orbit. I found that very interesting, and it's very easy to understand once you see a video like that, which is why
Exactly.
Yes. So, so thank you so much for appreciating our efforts. And what we're trying to do here is actually ensure that more and more people understand what this is all about, because it does sound complicated. I have always, been very scared of physics in high school and all of that. But now when I saw the video, it's like a renewed interest and, really excited about what's happening. Okay, let me bring back Swaroop Chatterjee.
Yeah.
Hi, Swaroop, did you see the video?
Yeah, it's wonderful, and really it's encouraging too. Lot of information, and it's really very informative.
Right. That is what. Do you have any question for Dr. Ranade regarding the Mars mission, regarding the MOM?
Yeah, just a small thing. Which I would like to know. What's the difference between the US maiden and India MOM? Just what's the basic difference? So
yeah, that is the question even I had in my mind, Dr. Ranade.
Okay, good question.
Yeah.
See, I mean, number one, I think in your this particular show that you were just did that you mentioned, it also talked about the Marvins in comparison to the money and this fuel thing, which is there.
Right.
No doubt, money is certainly on the higher scale. I think what is more important to understand in this scenario is the accuracy, the efficiency, and then the instruments which are sitting on the Maven. Because no doubt Maven is technologically very advanced mission as compared to Mangalyaan.
Atlas 5 is more advanced than a PSLV? That's what you're saying?
No. PSLV is a launching vehicle. I'm talking about the payloads. I'm talking about the instrument setting on the Maven.
Okay.
And then the objective that Maven is looking for and the objective that Mangalyaan is looking for.
Okay.
Because I think it will be very easy to first understand, because our Mangalyaan is going to be parked in the orbit of say 400 perigee and about 80,000 apogee. But this Maven is going to be about 150 kilometers at the perigee and about 6 to 6,500 apogee. That means it is very clear that this Maven is going to have the high result kind of an observations as compared to the Mangalyaan. And then again, the objective that Maven is looking for is to basically trying to analyze the impact of solar wind onto the Martian atmosphere. And as of today, I mean, the kind of instruments that we are dealing with are certainly not going to have that particular objective in the mind. And certainly because then again we are, in fact, the Marvin is also trying to look for the various other objects as well. So the kind of instruments which are sitting on the Marvin are certainly very high resolved with the high efficiency, and of course a lot of one can say the expectations are going to be very high, and the major cost of it has also gone into the manufacturing of all those instruments, of course, as compared to the Mangalyaan. But nonetheless, what is more important, again, we have to understand that we are able to achieve the same kind of an target with the less amount of fuel. And again, if you look at the trajectories that has been used by Indian Mangalyaan, as your animation by the team member that has been flashed, also talks about how incremental the orbit was being used in our case. But in their case, there was not incremental orbit happened in Marvin.
Okay.
Only one at the perigee, they have just gave a right amount of thrust, and it also requires a tremendous amount of fuel in sitting inside, and that Marvin had that capacity.
Right.
Like a 90,000 Newton thrust, where ours was just about a 450 Newton thrust that we have been going with the liquid approach motor.
So if we are successful, we are actually achieving the same thing with a lot less resource, isn't it? Is that's basically what I understood.
What you say is also not wrong, but I think it was altogether, it was a technology demonstrations on the international platform.
Right.
Like in entire the scenario, what we are looking for is at least we should be a great stakeholders in the days to come, where this India will show this entire globe that we also have a capability, especially in terms of the fuels as well as the vehicles that we have been using, like a PSLV.
Right.
And I'm also very optimistic that in the years to come that we will also be good in the cryogenics as well as which we are going to test it with GSL.
Absolutely. And also another very important thing that I don't think we should forget is that, whether we deny it or not, we keep talking about the race between India and China, the two Asian superpowers. And there is also a space race happening in Asia. But India seems to be making it to the finishing line first, as early as day after tomorrow. And in fact, in 1998, Japan's mission failed, and in 2011, China's mission failed. But this is India's maiden mission, and we seem to be winning. Dr. Ranade, huge achievement.
Exactly. You have perfectly underlined the, I would say, the achievements if we really going to be the successful. And really, it is a maiden one, and of course, the entire credit goes to our engineers and
Absolutely.
the scientists who have developed it. And I'm also, very, very optimistic about the success of this mission. And I'm also very eagerly waiting for the 24th early morning to get the good news for every one of us.
Absolutely, as we are all, as the entire nation is, and I'm sure especially Swaroop and Palash too, because they plan to go there after a few years and settle if they are selected. Okay, Palash, let me come back to you, joining us from Kolkata. Palash, how did you, I hope you enjoyed being on the show. I hope it was informative for you and you learned something.
Yeah, sure.
Yeah.
And the video was very good that was shown in the live.
Thanks to News Monk for sharing it with us. Thanks to them for sharing it. But Palash,
I have just one question to Professor. There is the ISRO said that there is a plan B if the trajectory, if the insertion is not as good, then there is a plan B. Then how that will affect the overall measurements of the scientific measurements?
Okay, what is plan B, Dr. Ranade? Very quickly, we have to wrap up. Yeah.
Okay, certainly. It's a good question that Palash asked.
Yeah.
Certainly, I mean, we are actually largely going to be dependent on this liquid apogee motor. But nonetheless, that is a plan A. And if we really get fell into that, then we will have to compromise at some level. And what is the compromise is nothing but like the desired orbit that we are looking for the Mangalyaan is about a 365 perigee and 80,000 apogee. And then if plan A doesn't get succeed, then we'll have to go with the plan B and we will be compromising with the orbit apogee perigee distance. But nonetheless, that is not going to really matter a lot as far as the science out of this entire mission is concerned. The maximum chances could be we will be dealing with a tremendous amount of trajectory corrections and all, by which we may be losing most of the time in all the trajectory corrections. Nonetheless, we are expecting the good results out of it.
All right, great. Thank you so much. And Swaroop, thank you so much for joining us. I hope you enjoyed the show. I hope you enjoyed being on the show.
Yeah, definitely. Really,
Great.
very excited.
Great.
Thank you for organizing this day.
No, thank you so much. Thank you so much for joining and speaking to us. And of course, we're all excited. It's a huge thing for India. Huge thing for India's space project. And of course, thanks to Dr. Arvind Ranade for taking out the time for us and talking to us and explaining what the whole technology is all about. Thank you so much. It was great having you. And that's it. Thank you, Palash, as well. Palash, Swaroop, and Dr. Ranade, thank you so much. Thank you so much for joining us on the show. So that's all we have right now. But if you have any video comments, if you have any extra information that you want to share with us, any comments, any questions, please write into us at India Post Live. Leave your video comments, leave your posts, and of course you can tweet us at #IndiaPostLive and @IndiaPostLive. Thank you so much for watching this show. Day after tomorrow, of course, a huge day when we will be aligning with the MOM, the Mars Orbiter mission will be aligning with the orbit of Mars, and we will be making our rendezvous with the red planet, and it will be India's maiden mission. So if it's a success, it's a huge thing for ISRO and of course for India. Thanks so much for watching. Take care. Bye-bye.